Hello there. Welcome to today's lesson. We are looking at the index laws. Previously, we looked at the introduction to indices and we defined what an index number is. And when you are writing a number in index form, then it means you are having a base and a power. So for instance, if I have a to the power of b, then it means my number is in index form. So when you are dealing with multiplication operations and division, there are laws that are applied when we have a number in index form. So the first law that we are going to look at is the multiplication law when looking at the indices. So we have the laws when we are multiplying. So what we do when we deal with multiplication of indices, we consider the base. So if a number is to the same base, we are having multiplication of numbers that are having the same base, but with powers that may be different or the same. So we add the powers. When the base is the same, we add the power. So for instance, if I'm having a number like a to the power of b being multiplied by a to the power of c, my base in this case is the same. So having the same base, we simply add our powers. So this will mean that this is just the same as a to the power of b plus the other power, which is c. So I'll have a to the power of b plus c. So when you are having numbers that are being multiplied that are in index form, we simply add the powers so that we get the solution to the sum. The second law we have is when we are dealing with the division. So when we are dividing numbers that are to the same base, what happens is, if the numbers are to the same base, we subtract the powers. What do I mean? So we are subtracting the powers in cases of division. So for instance, if I'm still using the same a, so I have a to the power of b divided by a to the power of c. We notice that my base is the same. So if I want to get the solution to this, then it means that I subtract my powers. So the solution will be a to the power of b minus c. So if you are having the same base and it is multiplication, we add the power. If we have the same base and it is division, we subtract the powers. The third law we have is the index law of power of a power. We could have a situation whereby a number is in index form already, but it is to another power. So what do I mean by that? I'm having a to the power of b, and at the same time, we have the power of c. So what does this mean? We are having two powers in this case. So in my simplification, then it means that this will be simplified by multiplying the powers, such that I'll have a to the power of b times the power of c, which gives us a to the power of bc. So those are the three laws of indices that we apply whenever we are having a number in index form. The first law we've dealt with, we are saying that we are having the multiplication law. If the bases are the same, we add the powers. If it is division, if the bases are the same, we subtract the powers. And when you are having the law of a power, then it means we multiply those given powers so that we get the solution to whatever problem we are solving. With that in mind, we can look at some few examples that require us to apply the laws of indices. So we have the questions on the board. We are required to simplify, giving our answer in index form. So in simplifying, we first find out which law are we supposed to apply, keeping in mind that we have the 3 laws. The first law, in the first case, we are looking at 7 to the power of 3 times 7 to the power of 5. So we are having multiplication. Our base is the same. So since our base is the same, then it means that the solution to this, we are having multiplication. Base is the same, so we simply add our powers. So we will have 7 to the power of 3 plus 5. That is the power of the first 7 and the power of the second 7. That is 3 plus 5. So we get that 3 plus 5 will give us 8. So the solution will be 7 to the power of 8. Part B. We are still using the same law because it is still multiplication, and we are having the same base. This is our base, in this case is 2. So we are having 2 to the power of 4 times 2 to the power of 5 times 2 to the power of 3. So in multiplying and giving the solution to this, considering that they are to the same base, we simply add our powers. So I'll have 2 to the power of, my first 2 has the power of 4, the second 2 has the power of 5, so plus 5, and the third 2 has the power of 3, so it will be plus 3. So we have 4 plus 5, which is 9. 9 plus 3 gives us 12. So my solution will be 2 to the power of 12. We are leaving our answers in index form because that is what the question requires us to do. Part C, we have 10. So we have 10 to the power of 10 times 10 to the power of 10. We discover that my base is the same. It is multiplication. So since the base is the same and we have multiplication, we simply add the powers. So I'll have 10 to the power of 10 plus 10, and 10 plus 10 gives us 20. So that means that I'll have 10 to the power of 20 as the solution to that given equation. The next example we have is 8 to the power of 4 divided by 8 to the power of 2. So this is division. Our base is the same, so it means we subtract the powers. So I have 8 to the power of 4 minus 2. So that will mean 4 minus 2 gives us 2. So 8 to the power of 4 divided by 8 to the power of 2 gives us a solution of 8 to the power of 2. We can try this and try and prove why the division gives us the subtraction sign. When we have 8 to the power of 4, it simply means that I'm having my 8 repeated 4 times. So I'm having repeated multiplication of 8 4 times. So I have 8 times 8 times 8 times 8. Then we are dividing. So divide by 8 to the power of 2. So it means that I'll have 8 times 8 to the power of 2. It means that I'm repeating my multiplication twice. So that when 8, I cancel out the first 8 and that, then I have the other 8 cancelling out. We are left with 8 times 8, and 8 times 8 is simply 8 to the power of 2, because you are leaving our answer in index form. So 8 has been repeated twice, so we discover that we have 8 to the power of 2. So it simply means division, you subtract the powers if the numbers are to the same base. Another example we have is 4 to the power of 2 and also to the power of 3. So we have a power of a power, so that means that we will have 4. When we have a power of a power, it simply means we multiply the powers for us to get the required solution. So I have 2 and 3 as the powers, so it means I'll have 2 times 3, which will give us 2 times 3 simply gives us 6. So this means that this is 4 to the power of 6. So when you're having a power of a power, it simply means we multiply the given powers to get the solution to whatever question that we have. So the next example, we have 5 to the power of 3 divided by 5 to the power of 3. And we discover that 5 to the power of 3 means that my 5 has been repeated 3 times. So I multiply 5 times 5 times 5 divided by 5 times 5 times 5. So what does this mean? If I divide these, I'm left with 5. The first 5 cancels out, the second one cancels out, and we discover that the other one also cancels out. And we are left with 1 as our solution. So what am I trying to say in this given situation? When I have 5 to the power of 3 divided by 5 to the power of 3, we discover that this is to the same base and division. A number to the same base, division, we simply subtract the powers. So it means that I'll have 5 to the power of 3 minus 3, and 3 minus 3 gives us 0. So this means that this is 5 to the power of 0. And 5 to the power of 0, we are finding out that 5 to the power of 0 is simply 1. So what do we mean? Any number that is raised to power 0 will give us 1. So this is a conclusion that we are coming up with, that when you're having 0 as your power, it means that that value is simply 1. So any number So any number to power 0 will give us 1. So whenever you get any given number, whatever it may be, not necessarily 5, even if I have a as a number that we are having. So I can use an example of a. and find out if it will give us the same value. So if I have a to the power of 5 divided by a to the power of 5, then it means that I have a to the power of 5 minus 5 using the laws of indices. So 5 minus 5 will be 0. So this means that this is a to the power of 0. We want to prove if a to the power of 0 is 1. So it means that a to the power of 5 is repeated multiplication 5 times. So we have a times a times a times a times a divided by a times a times a times a times a. So what does it mean? This a cancels out with the one of it. This one will cancel out with the second one, the third one, and the third one. Fourth one will cancel out. The fifth one also cancels out. And that means that I'm left with 1 over 1, which will simply be 1. So what does it mean? A to the power of 0 is simply equal to 1. So any number to the power of 0 is 1. So we can start with whatever we have on the board. Question 2, we are asked to simplify each of the following by combining various index laws. So we are going to combine the laws that we've learnt in simplifying the equations that we have. So the first equation we have is 4 times 4 to the power of 2 to the power of 3. So when we are looking at this, we discover that we have the same base, but apart from having the same base, our second number has a power of a power. So it means we first simplify the second part of our question before we go ahead and simplify the combined part. So we are starting with 4 to the power of 2 to the power of 3. So it means when we have a power of a power, we simply multiply our powers. So 4 times 4 to the power of 2 to the power of 3 means that I have 4 to the power of 2 times 3. And 2 times 3 is 6. So this means that we have 4 times 4 to the power of 6. This is simply the same as 4 to the power of 1. So we have the same base, multiplication, we add the powers. So this will mean that I'll have 4 to the power of 1 plus 6, which gives us 4 to the power of 7. The second part, we have 13 to the power of 11 divided by 13 to the power of 0. So here we apply the 0 index, and when we are dealing with 0 index, what we say is that any number raised to the power of 0 is 1. So this means that I have 13 to the power of 0, meaning this is equivalent to 1. So this means that I have 13 to the power of 11 divided by 1. And 13, any number divided by 1 will give us that value. So this means that I'll simply remain with 13 to the power of 11. Next, we have 2 to the power of 10 divided by 2 to the power of 9. So this is the same base division. We subtract the powers. That means that I have 2 to the power of 10 minus 9 and 10 minus 9 is simply 1. So this gives us 2 to the power of 1. And any number raised to power 1 is simply that number. So this means that this is just 2. Then next we have negative 1 to the power of 11 to the power of 2 times negative 1 to the power of 2 to the power of 11. So we are having powers of powers in this given equation. So it means that we first simplify the power of power by multiplying those given powers. So this means that I'll have negative 1 to the power of 11 times 2, then multiplied by negative 1 to the power of 2 times 11. When we multiply, we are having 11 times 2 gives us 22. So this means that this is negative 1 to the power of 22. Then times negative 1, 2 times 11 is just 22. So I'll have negative 1 to the power of 22. Then we need to, this is a number, negative 1 to the power of 22 times negative 1 to the power of 22. What we are looking at, we are finding out which type of a number do we have as our power. And we discover that we have an even number as the power. So if our number is negative, we already know that 1 raised to any number, if I have 1, this is 1 and not negative 1, so I have 1 raised to any number. If it is a, will simply give me back 1. Because 1 times 1, however many times you will multiply the 1, you will still get 1. But in this case, what we are having is negative 1 and not 1. So we need to find out our power. If the power is an odd number, if we are having the power as odd number, then it means our final result will be negative 1. But if our power is an even number, then it means our final result will be a positive 1. We can just try and investigate using some lower power that is not 22. So I can use a power like maybe 3. If I have negative 1 to the power of 3, 3 is an odd number. So it means my negative 1 is repeated 3 times. So I have negative 1 times negative 1 times negative 1. So what does it mean? If I start with the first 2, then it means that negative 1 times negative 1, a negative number times a negative number will give us a positive number, so it gives me a positive 1. So combining with the remaining negative 1, so I have a positive number times a negative number, it gives me a negative number, which is negative 1. So we discover that when your power is an odd number, then our answer will be a negative 1. But what if it is an even number? An even number is a number like 4. So for instance, if I have negative 1 to the power of 4, I have negative 1 to the power of 4. It means my negative 1 is repeated 4 times. So I have negative 1 times negative 1 times negative 1 times negative 1. So this means that negative 1 times negative 1 gives us positive 1. Then times negative 1 times negative 1. What does it mean? That when I multiply this, positive 1 times negative 1, I'll get negative 1. So combining with the last one, I'll have negative 1 times negative 1. And a negative times a negative will give us a positive number, which is positive 1. So that is why we are concluding and saying that negative 1 raised to an odd number will give us negative 1. But negative 1 raised to a positive number, an even number, will give us positive 1. So we are concluding our calculation and saying that we are having negative 1 to the power of 22, and 22 is an even number, so it means that this one will give me a positive number, which is 1 times negative 1 to the power of 22. 22 is an even number, so it gives us a positive 1, and 1 times 1 is simply 1. There are some situations whereby you are asked to simplify the index numbers, but you discover that the numbers are not to the same base, but they can be expressed to the same base. So what does it mean? You are required first to change the numbers to the same base before you go ahead and simplify the required numbers. Let us just look at a few cases whereby we need to change the bases of our numbers before we simplify. So we have an example, 555 divided by 15. So in simplifying this, we need to find out which are the factors that are making up 555 and 15. And we discover that 555 is simply the same as 111 times 5. Then 15 is the same as 3 times 5. So in simplifying this, I have 111 times 5 divided by 3 times 5. Then I have the same base. In this case, the second part of we have 5 on the numerator, we have 5 on the denominator. So it means that these 5 and 5 can cancel out. Then we have 111 and 3. We just looked at the divisibility test earlier before looking at the indices, and we discovered that for a number to be divisible by 3, you simply add the digits that are making up the number. If the sum will be divisible by 3, then it means the number is divisible by 3. So if I add the 1, I have 1 plus 1, which is 2. 2 plus 1 gives me 3. So 3 is a number that is divisible by 3. It means that my 111 is divisible by 3. So 3 into 3 once, 3 into 111 is 2 because of 9. No, 3 because of 9. We are left with 2 into 21. We have 7. So in my simplification, then it means that I have 37 times 1 divided by 1 times 1, which gives us 37 as the answer. So I just want us to find out what are these factors that are making up 1,456. So 1,456, finding out the factors, then we have 2 into 14, 7, 2 into 5, 2. We are left with 1. This makes it 16. 2 into 16, 8. Then the next factor is still 2. 2 into 7, we have 3. We are left with 1. So 2 into 12, that is 6. And 2 into 8, 4. 2 into 3, 1, 2 into 16, 8, 2 into 4, 2. 2 into 18, 9, 2 into 2, 1. So those are some of the factors. 91 is a prime number. So that means that we have the factors 2 to the power of 4 times 91. Then the factors of 16, we have 2 into 16, 8, 2 into 8, 4, 2 into 4, that is 2, 2 into 2, we have 1. So 16 is the same as 2 to the power of 4. So those are the figures we have, and we want to use the factors to simplify our equation. So that means that I'll have 1456 will be the same as 2 to the power of 4 times 91. Then 16 is the same as 2 to the power of 4. So I'm having 2 to the power of 4 and 2 to the power of 4 on the other side. So this means the same as 2 to the power of 4 times 2 to the power of 4. I'm collecting the ones that have the same base, then times 91. So this means that I have multiplication, the same base, we add the powers. So this will mean that I'll have 2 to the power of 4 plus 4 times 91. This means that 2 to the power of 4 plus 4 is 2 to the power of 8 times 91. So we were using the factors to simplify our calculation. So this means that our values are 2 to the power of 8 times 91. So this means that these are the factors that we've been looking for. Another sum that we need to simplify using the factors is 3,600 divided by 48. So we want to use the factors, so that means I find out which are these factors that are making up 3,600 and get the factors that are making up 48. So 2 into 3,600 into 3, that is 1, into 16, 8, then we have the zeros. 2 into 18 is 9, then we have the 2 zeros. 2 into 9, that is 4 because of 8, into 10, 5, then the 0. 2 into 4, 450, into 4, that is 2, into 5, 2, into 10, 5. Then next we have 5. 5 into 225, that is 4. 5. 5 into 45, that is 9. Then 3 into 9 is 3, and 3 into 3, 1. So this means that I have 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 2. Then 48. The factors of 48, these are the factors of 3,600. The factors of 48, 2 into 4, that is 2. 2 into 8, we have 4. 2 into 2, 1. 2 into 4, 2. 2 into 12, that is 6. 2 into 6, 3. Then 3 into 3, 1. So factors of 48, we have 2 to the power of 4 times 3. So if I simplify my expression, then this is what it means, that I'm having 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 2 divided by 2 to the power of 4 times 3. So if I simplify this, then I have 2 to the power of 4 divided by 2 to the power of 4. Subtracting the powers, this is 4 minus 4, which gives us 0. So 2 to the power of 0 is simply 1. So 2 to the power of 4, 2 to the power of 4 cancels out to give us 1, times 3 to the power of 2 divided by 3. This means that I have 3 to the power of 2. 3 is simply 3 to the power of 1. So I have 3 to the power of 2 minus 1 because it is division. Division, the same base, we subtract the powers. So this will mean 2 minus 1. I'll be left with 1. So it means times 3 to the power of 1. And any number to the power of 1 is simply that number. Then times 5 has not been simplified anywhere. So it means I'm left with 5 to the power of 2. We can go ahead and simplify this. This is the same as 3 times 5 to the power of 2 is 25. Then 3 times 25 gives us 75. So in this case, I've been required to change my 3,600 to a base. So I have these bases, that the factors that are making up 3,600, so that I have 2 to the power of 4, 3 to the power of 2, and 5 to the power of 2. Then 48 is 2 to the power of 4 times 3. Then we go ahead and simplify so that we come up with 1 times 3 times 2 to the 5 to the power of 2, which gives us 75. So we have the question whereby we are asked to change the base and simplify using the smallest possible integer. So we need to find out what is the smallest possible integer making up the number that we have. Then we simplify our equation. So we have 8. So this means that we have to get the knowledge of the factors that are making up 8 so that we find out which is the smallest factor that is making up 8. And we discover that the factors making up 8, we have 2 into 8, that is 4, 2 into 4, 2, 2 into 2, 1. So factors making up 8, if I have to express 8 in index form, 8 is simply 2 to the power of 3. So since we have the knowledge that 8 is 2 to the power of 3, then our 8 was to the power of 4. So it means that I'll have to make up a power of a power. So this means that I'll have 2 to the power of 3 to the power of 4. And when we have a power of a power, we simply multiply the powers to get the solution. So this means that I'll have 2 to the power of 3 times 4. 2 to the power of 3 times 4. 3 times 4 is 12. So I'll have 2 to the power of 12 as the solution. Next, I have 81 to the power of 5. So I need to find out the factors that are making up 81 for me to get to know what is the smallest possible integer in this case. So I have 81, finding the factors, the lowest, this is 8 plus 1, which is 9, so means 3. 3 into 81, that is 2, into 21, 7. 3 into 27 is 9. 3 into 9, 3. And 3 into 3, that is 1. So this means that 81 is the same as 3 to the power of 4. So having known that, then we go ahead and simplify. 81 to the power of 5. 81 we've already said is 3 to the power of 4. But our 81 was to the power of 5. So it means to the power of 4 to the power of 5. So that will mean that 3 to the power of 4 to the power of 5, we multiply the powers. That means I have 3 to the power of 4 times 5. And 4 times 5 is 20. So it means that this will be 3 to the power of 20. So with that, it brings us to the end of the introduction to indices. Just to review whatever we've been doing in introduction to indices, we looked at the numbers in the first case, and we had two types of numbers. A number is either a prime number or a composite number. And we defined our prime numbers as a number that has only two factors, that is 1 and itself. Then composite numbers has more than two factors, whereby you could be having 3, 4, 5, and so on factors. So we say that that will be a composite number. So these composite numbers can be expressed in index form. And how do we get this index form? For us to be able to express the numbers in index form, then we talked about the prime factors. We need to know what are the prime factors making up the number. Decompose your composite numbers so that you get the factors that are making up that given number. Then the number of times the number has been repeated will represent the power of that given number. Then finally, we've looked at the laws of the indices. And in the laws of indices, we've dealt with 3 laws of indices. And the first law was law of multiplication, in that when you're having the same base and we are multiplying the numbers, then it simply means we add the powers. When we are having division and we have the same base, then we simply go ahead and subtract the given powers. Then the last law of index law that we've dealt with is the power of the power. So when you are having a number raised to a power of another power, then it means that you simply multiply the given powers. Then finally, we could be having a situation whereby you have a number that has been written in index form, but it can be changed. The base of the given number that has been written can be changed. So when there is possibility of changing the base of the given number, just find out what are the simplest integer or the smallest integer that is making up the number. And after you've obtained the smallest integer making up the number, you can express that number in index form and simplify the given situation. So that brings us to the end of the introduction to indices. Thank you.
Welcome.